So bitwise operators are a bit different from the other operators, and we would be learning about them in this video. So bitwise operators work at bit level or perform bit by bit operation. We have the following bitwise operators in Golang: bitwise AND, bitwise OR, bitwise SOR, right shift, and left shift. Let's learn about these operators with some examples. So first up, we have bitwise and it is denoted by the single ampersand sign. This operator takes two numbers as operands and does AND operation on every bit of two numbers. So let's see how bitwise AND is going to work for 12 and 25. The decimal representation of both these numbers is given here. So if we perform AND operation here, we see that we get the resultant bit as 1 when the corresponding bits of both the operand is 1, while we get 0 when either one of the operand bit is 0. So the result we get over here is 8 in decimal number system. Let's see the code now. So over here we have declared two integers, 12 and 25, and then we are calculating the AND operation and storing it in a variable z. On printing z, we get our value 8 as expected. Next up, we have the bitwise OR, and it is denoted using the vertical bar sign. So bitwise OR takes two numbers as operand and does OR on every bit of two numbers. Let's see how OR is going to work for 12 and 25. So if we do an OR operation here, we'll see that we get 1 when even if one bit of the two operands is 1, while we get 0 when both of the bits are going to be 0. So this entire result is 29 in decimal number system. Let's see the code now. So we have declared our integers, and to calculate the OR operation, we have placed a single vertical bar sign between x and y. We have stored the value in z, and it gives us the result 29. The next operator is the XOR operator. So it takes two numbers as operand and does XOR on every bit of two numbers. So what is XOR? The result of XOR is 1 if the two bits are opposite. So over here, if we do the XOR operation, so XOR is denoted by the caret symbol. The output of bitwise XOR is going to be 1 when both of the bits are opposite, while it's going to be 0 when both of the bits are same. The XOR operation over here gives us 21 in result. Let's see the code now. So we have our integers, and to calculate the XOR between them, we place a caret sign between x and y. We store the value in z, and we get 21 in the output. The next operator is the left shift operator. It shifts all bits towards left by a certain number of specified bits. So for example, if we say we have a number 212 and we want to shift it by one bit, the output is going to look something like this. So we have shifted all the bits towards left by 1. And the bit positions that have been vacated by the left shift operator are filled with 0. So if we shift 212 by 1, we get 424 in our output. Let's see the code for this. So we have declared and initialized our integer with the value 212. And when we left shift it by 1, we get 424 as the output. Then we have the right shift operator. So it shifts all bits towards right by a certain number of specified bits. So if we have in our example the number 212 and we want to right shift it by 2 bits, our output would look something like this. So we've basically shifted all the bits by 2 bits over here, and all the excess bits to the right are discarded. So this gives us the result 53. Let's see the code now. So we have declared and initialized a variable x with a value to 112, and we have stored the result of shifting it to the right by 2 bits in the variable z. When printing z, we get our value 53. That is all for this lecture. Head over to the labs and get some hands-on practice.